All right, welcome back to AP Biology for Chapter 5. Just a couple things that I want to make sure you're accessing. Um, One, you should have this slide presentation. Two, you should have your reading guide. Hopefully that'll load. Looks like this. This will be really helpful for certain pieces as far as the dehydration, synthesis, and hydrolysis reactions right there. And then I'll probably go through some of this other stuff as well. Once I get into the different videos for your macromolecules, you'll want this chart available as well, or at least writing something similar in your notebooks. All right, so here we go. Chapter 5, just so you're aware, there will be 5 different videos for this chapter. I will be doing an intro video, which is this one, which will go into some background as well as how macromolecules are built and broken down. And then there will be 4 other videos on each of the different macromolecules. So here we go. First of all, I would highly recommend you watch this video. Mr. Anderson does, again, a great job of kind of explaining these materials probably better than I ever could. So highly recommend that. If we were in class for this, you would be watching that in class. So again, you have access to this entire presentation. So click on that and highly encourage you to watch that. All right. So the next level of organization that we're going to look at is macromolecules. We kind of looked a little bit on atoms, molecules like water, and into compounds, and now macromolecules, which if you broke down that science term, macro meaning big molecule. Okay, so very large molecule, and they are composed of smaller molecules. And they are very complex, and we'll look at the structures of each of these. Macromolecules are known as polymers. So if I were to break down the term polymer, I would break it down right down the middle. And poly, that prefix means many. Okay. And the suffix mer means part. Okay. So macromolecules, what is a polymer? Many parts. Okay. They are built, it says, from monomers. Let's break down that term. Mono meaning one. Mer again meaning part. So let's look at this again. Macromolecules are built from many parts. Are many parts built from one part. So in other words, if I were to draw something that looks like this, we would say this is maybe a polymer. And so the whole thing is the polymer. And if I have just one of those, we would say that that is a monomer. So if we look comparatively to a train, the entire train is the polymer, and one rail car would be a monomer. So each one of these 4 macromolecules has its own monomer. We'll talk about those in the coming videos. And that's kind of what makes them unique, and their structures will be very different because of that. So just again, a polymer, long molecule consisting of many similar building blocks called monomers, and those specific monomers make up each macromolecule. So if we looked at an example of that, for proteins, an amino acid is the monomer for the polymer of a protein. So if I were to draw that same diagram again, each one of these would be an amino acid. That's the monomer again. And the whole thing then is a protein. Okay, so just keep that in mind. It's just a specific example of how those terms can fit. All right. Now, this is very, very important. I highly encourage you to have your reading guide out and be taking notes on this diagram. I'm going to break down these terms, and again, very, very important for your test. So the first type is called a dehydration synthesis reaction. If you thought about the term dehydration, you probably think of, when you're dehydrated. What's going on when you're dehydrated? You're lacking water. Okay. So in this case, how we're going to remember dehydrate is to take water out. Okay? To take water out is what we're doing in dehydration. Now, what does this term synthesis mean? Well, you should think of synthesis as to build. All right, so what are we doing in dehydration synthesis? We're taking water out to build. That's what it is. So if you can break down those terms, you can remember this. Sometimes it also is called a condensation reaction. And the reason for that is because water is taking out. If you think about condensation on like the outside of a cold water bottle in the summer, it's that water on the outside that's condensating. All right. So if we look at the diagram here, we have two monomers, or we have two molecules here. We have a monomer being linked to the larger polymer. Now, what are we doing? We're taking water out. So here's that water that was taken out. Where did those come from? Here's that hydrogen and hydroxide group. Put those together, you get a water. All right, and what do? We built that bond there. So we added a monomer on. All right, one last thing to note. When we build in this bond, we would say energy is stored. Okay, so again, we took water out to build the polymer, and energy is stored in that bond. And that's everything you should need to know about dehydration synthesis. Go back and review that if you need to, but very important. We will be reviewing that probably next week before your test. All right. The opposite of that then is what we would call hydrolysis, also sometimes known as digestion or a digestive reaction. Okay, and you can probably guess what if it's sometimes called digestion, what's going to happen? Well, if we break this term down, hydro meaning water, and what are we doing? We're using water in this case. Now, the suffix lysis means to break. So you might guess why. You could probably understand why we would call it digestion, because we're breaking this polymer down. So this looks like the polymer that we just built on that previous slide, right? What are we doing? We're using water. Water is going to come in and it's going to break that bond. Here's those two parts of water again. And what do? We broke off that monomer. So we broke it down. Now the last piece is how is energy involved. In this case, energy is released. Okay. So by breaking down our food, we get energy. It's an example of when we would do hydrolysis. When would we do dehydration synthesis? Well, the plants would maybe do that when they're building that molecule. Okay. We do that in our bodies too. We build fats, we build muscle and things like that. So we can build that. All right. So those organisms share the same limited number of monomer types. Each organism is unique based on the arrangement and how we use those monomers in the building polymers. And the variety in the polymers is immense because of how we use those monomers uniquely. And with that, that's it for this one. Your next one will be on carbohydrates.